Ms. Mello is going to talk about the city of Milford. City combats odor and corrosion with super oxygenation. Before you start, I want to apologize. I unfortunately need to leave. I wanted to be environmentally friendly and took the train instead of the car to come here, but now I'm short in time and must leave. So I'll leave you with Mr. Bakhtari. It was a pleasure meeting you all.
Perfect. Well, I'll take over. Thank you. Thanks, y'all, for sticking around that long. It's a real commitment. Recently, somebody told me there used to be a TV show, game show, that was called Are You Smarter Than a Fifth Grader? I've never watched it, but I do have a fifth grader at home, and while I can still help him with his math problems. When it comes to technology, every once in a while, he comes home with something where he can actually learn a thing or two. And so the other day, he came to me and said, "Mom, you give a lot of PowerPoint presentations, don't you?" I said, "Yes." He's like, "Well, PowerPoint presentations are out. So you got to give a Prezi." And I was like, "What? Has anyone ever heard or worked with a Prezi before?" Oh, very good, very good. Well, he helped me set up this Prezi, so please enjoy my first try at a Prezi. Trying to be creative. Yeah, the title of my presentation is, it's about a project that we've done with the city of Milford in Connecticut, and how they address their odor and corrosion problems with a pure oxygen system. So this is going to be the outline of my presentation. It's the collection system for the city of Milford. It's a very large collection system. It was plagued with odors, and they kind of pinpointed the source for the odors to that Gulf Pond pump station. When you look over here, the Gulf Pond pump station pumps through two force mains into one gravity line that leads to the West Avenue pump station, and then from there, it's pumped a short distance, but then mainly flows by gravity into the Housatonic wastewater treatment plant. The odors that they were experiencing are mainly in this area right here, at that gravity line downstream of the force mains and at the West Avenue pump station. You look at the Gulf Pond pump station, it pumps about 3 million gallons per day. But you see that at the wet well, they measured sulfite levels. They were actually non-existent. And so the pump station, they had a positive ORP. The pump station itself was not an odor source. But then, like I said, it was a very long dual force main. It's 13,200 feet long, so that's almost 4 kilometers. 24 and 20-inch, fairly large force main, dual force mains that were actually operated combined as well at all times. It was they only had manual valves to like turn one or two off or like shut them off, and they never really used those because they needed the capacity of both force mains for rain events. So therefore, during summer days when it wasn't raining, obviously you have much less flow, so the sewage sits in the force mains for quite a long time. They experienced hydraulic retention times in those force mains for over 12 hours. Which, of course, I think we kind of talked about this a little bit. Really, the two main factors that create the odors are, like, for one, the temperature. Higher temperatures, of course, creates higher odors. And then the detention time. So the longer the sewage sits in the line, the more time it has to create sulfites, and the higher the sulfite levels at the discharge. So in this case, these are H2S concentrations at the discharge of that force main. And you see they go quite high. They go above 700 parts per million. This is on a nice warm summer day. And you know that obviously that is a major odor problem, but it's also, these levels are unsafe for us to be around. As we all know, above 300 parts per million, that's pretty much deadly concentration. So we don't want to be exposed to that. So it was not just an odor problem, and they did have a condo complex right next to that discharge manhole. So they were constantly complaining, but it was also a matter of worker safety. So what causes the odors? I know we touched on this before. I just like to show this little slide as a reminder. So of course we have the BOD degrading bacteria in our sewer pipe. And when we look at this sketch here that everybody is familiar with. We have the pipe wall over here, and then what's outlined in red is the slime layer with the BOD-degrading bacteria. And the reason why I like to show this slide is to remind everyone that this BOD-degrading bacteria needs an needs an oxygen source. And so the preferred source of oxygen obviously is dissolved oxygen from the water. But under normal, regular conditions, oxygen, as we all know, is very limited. It's going to be consumed fairly quickly. And once the oxygen is consumed, the bacteria switches and uses nitrates as an oxygen source. And the nitrates are also limited. But once the nitrates are consumed, the bacteria switches over and uses sulfates as an oxygen source. And there's an unlimited amount of sulfates in our residential wastewater, so the bacteria will never stop degrading BOD, and it'll just switch between those 3 oxygen sources as they become available. The problem that we have with the bacteria using the sulfates is they reduce them to sulfides, and now we have the sulfides in solution in the water phase. And wherever we have a headspace, the sulfides can come out of solution as H2S. And that, of course, is our odor source. But then it doesn't stop there. I know we're talking about odors here, but really it's very important with the H2S. Once the H2S hits the crown of a pipe, or in headworks, buildings, any type of the walls or the equipment, there's a different set of bacteria that converts H2S to sulfuric acid, which now creates this acidic condensate and creates quite a bit of corrosion damage. So with the odor comes the corrosion. So the odor is really just an indicator that you have corrosion going on in your lines. In this case, this is now the interceptor that these 2 force mains discharge into. It's about a 1-mile run, 36-inch diameter interceptor, and the entire ductile iron pipe was perforated. The manholes were deteriorated, so they had to replace the entire mile of sewer line and all the manholes. And then in addition to that, they also had to replace the, oh, hold on, not there yet. This is kind of what they look like, these pipes. These are actually from a different client of ours, the city of Columbia, Tennessee. They pulled these pipes out of their ground. They were 9 years old. And the city of Milford, they looked like that. They actually gave me a paper-thin piece of their ductile iron pipe. It's scary. And I show these pictures across the country, and I always have people sitting and nodding their heads in the audience because everyone is starting to see this. The infrastructure is failing at quite a rapid rate. So at the West Avenue pump station, these are the H2S concentrations that we see in the wet well there, or the manhole right before it discharges into the wet well. You see quite a bit of the sulfides have been stripped out, obviously, in that interceptor before. So the H2S concentrations are lower than right at the discharge of the force main, but they're still significant. You still see spikes of 200 parts per million, which is obviously very high. So likewise, just as in the interceptor, they had a lot of corrosion damage in that wet well. So they had to replace the entire wet well, and they also had to replace all the HVAC equipment and the electrical equipment. All of that was corroded after a fairly short amount of time. Another picture of a beautifully corroded manhole. I did some research on the rate of corrosion, and this is something I found in an ASCII manual for manhole rehab. So at H2S concentrations of 20 parts per million in the headspace, which we all know is not very much, especially not when you're dealing with concentrations of over 200 parts per million. At 20 parts per million, concrete corrodes at a rate of 1 inch per 5 years. So when you consider you have like 5-inch maybe thickness of your concrete manhole, it doesn't take very long until that is compromised. It's just a quote from the EPA. So, and we were seeing that fast degradation of the infrastructure pretty much across the country everywhere. So again, from the West Avenue pump station, the flow goes mainly by gravity line to the wastewater treatment plant. At the wastewater treatment plants, they have an odor scrubber at the headworks, so they still experience some odors. They're not quite as high, and they can be handled by the scrubber. So this is our collection system, but these problems were significant, obviously. So the city hired AECOM to do an odor study and to kind of help them with this problem. And this is what AECOM came up with. Ta-da! The solution. So Ecom took a two-pronged approach to this. For one, they optimized the force main operating conditions to reduce the retention time. And then second, they installed a super oxygenation system to keep the sewage fresh and prevent any sulfide formation. So what they did first, like I said, they had over 12 hours hydraulic retention time before, and they really wanted to reduce that. And it wasn't really smart to use these two force mains like on a continuous basis where the flows varied quite a bit. They went anywhere from below 2 million gallons per day all the way to 7 or even higher. So that's quite the wide range. So what they did, they installed some valves that can be operated magnetically or automatically. And they used just a small force main for the really low flows. And then at flows from 2 to 5 mgd, they would use the 20 and the 24-inch alternately. And they would just like switch every 2 hours, they would switch back and forth, just so to make not have the sewage sit too long in one line. So we'd have like a maximum extra retention time of 2 hours in one force main, and then we would flush it again. If the flows rise above 5 mgd, they would use the 24-inch, and then over 7 mgd, they would use both in parallel. So with this optimization of the force main, they were able to reduce the hydraulic retention time to anywhere between 2 to 7 hours. So 7 hours was the worst case scenario, which is still enough to cause some significant odors. Ooh, I need to hurry up. Talking way too much. Let's get to the oxygenation system. This is one of the oxygenation systems that they installed there, and you see this stainless steel cone. It's basically a oxygen transfer device. And in this cone, they're dissolving pure oxygen gas, and then they're adding the dissolved oxygen back to the water to give the bacteria their preferred source of oxygen, the oxygen, so that the bacteria will not touch the sulfates. And with that, they're effectively preventing sulfide formation. So I'll show you how that works. So it's essentially a side stream system of your force main flow. So in this case, your force main would go down here, and you're taking a side stream with a small side stream pump. You're pumping the flow into the top of the cone, and that's where you're injecting the pure oxygen gas. And then the whole idea behind this cone-shaped device is that you have a high water inlet velocity going into the cone that pushes the oxygen bubbles into the middle of the cone, splits them up, and creates this really fine bubble swarm. And then as the cone widens, the water velocity slows down. We're down here at the bottom. The water now moves slower than the buoyant velocity of the oxygen bubbles. So the bubbles can't get out of the bottom because they move up faster than the water that exits the cone. And they can't come out of the top because the water that comes back in pushes them back in. So they're trapped inside of the cone, and they're held in suspension until they're dissolved. And then what comes out of the bottom is water with an elevated DO level, so the oxygen is fully dissolved. And with that, we're getting an oxygen transfer efficiency of 95%, even though we're using raw wastewater. It's significant. And the discharge can be anywhere between 40 to 150 milligrams per liter DO or higher. It really depends on how much pressure is available. And I'm skipping the video. Here's just another picture of the setup. So you would have the force main pump pumping down this way. We're taking the side stream, oxygenating it, and blending it back in. And then the way we design this is we look at the hydraulic retention time in that force main, because you have an oxygen uptake rate by the BOD degrading bacteria, and that uses about 10 milligrams per liter per hour that the sewage sits in the line. So when we now have a maximum hydraulic retention time of 7 hours, we need 70 milligrams per liter DO to maintain aerobic conditions in that force main. And so that's what we're doing. We're adding 70 milligrams per liter here, and that'll last us 7 hours so that we still have aerobic conditions at the discharge. And with that, these are pictures. These are the pumps. Don't get dizzy now. This is the control panel. It gets a signal from the force main flow meter, and then it calculates the actual hydraulic retention time feeds the right amount of oxygen. So everything is flow paced, and and administers that through that oxygen flow control panel in here. And then, of course, you need an oxygen source. So you can either, in this case, they have liquid oxygen that was brought to the site just by a local supplier. The alternative would be to have an on-site oxygen generator that generates oxygen on demand right there. So again, the detention time was cut down to 2 to 7 hours, which is something that can be handled with the pressure in the line by the oxygenation system. And with that, they're now seeing these concentrations at the discharge of that force main. So you have, this is without the oxygen going, and these were rainy, cooler days, so the concentrations are lower. They only go up to 40, up here to 80 parts per million. But they turn the system on, and right away, the bacteria starts using the oxygen instead of the sulfates, and it's preventing sulfite formation. So it flatlines the H2S because it's simply not prevented, not formed. And then this is the odor log that we're using to, and then it flows, you know, this 1 mile by gravity to the West Avenue pump station, and really one of the goals was to protect that pump station as well. And these are the concentrations at that pump station still. So you're still seeing the effect over there. It's still down to 0, except for this little bump, which was a communication failure, and this was during startup, they didn't feed oxygen for a couple of minutes. And you can see how right away the bacteria switches. It's still active, it just uses sulfates again, starts producing sulfites. So, I made it. With that, as conclusion, so the operating costs are extremely low on that system. They are buying the liquid oxygen for about 6 cents per pound. So the daily cost is about $50. There's very low maintenance because really the only moving part is that side stream pump. Of course, you have the electricity for the pump, but the pump is just there to overcome the head loss through the cone. It's not actually pressurizing the cone. So it's a very low horsepower pump. Maintenance, the LOX equipment is maintained by the supplier. And yeah, you've seen the results. So they completely eliminated H2S, and that's really something that we see with these systems. Wherever they are a technical fit, that's the results that we're getting. So with that, I'll open it up for questions. Thank you.
Thank you so much. Questions? No. I had one. Before, I've seen this kind of solution, but they always had to have liquid oxygen or something, and I think that was one of the reasons some people weren't using it. But the oxygen generator, what is the costing compared to the one you show here?
Compared to the liquid oxygen as a comparison?
Yeah,
or?
like a daily cost would be considerably more, or about?
No, so with the oxygen generator, of course, you have the capital outlay for the equipment, but then it's actually a lot cheaper. You can produce gaseous oxygen with an oxygen generator for about 2.5 cents per pound, versus you buy it for like 5 to 6 cents. So you see kind of a payback of about 3 to maybe 5 years for the oxygen generator. You know, it's really in that sense, it becomes a preference of the client if they want the hands-off, you know, no maintenance solution with a tank, or they don't mind maintaining the equipment and just having a small footprint oxygen generator.
Safer, right? Compared to liquid oxygen being pumped.
Although I always tell everyone, you know, the LOX tanks, they are in every hospital's yard, and they're usually fenced in, so the maintenance crew shouldn't ever touch those, so they don't really have anything to do with them. They're maintained by the gas supplier, so yeah.
Thank you so much.
You're welcome.
Any questions? No? Okay. Let's
Thank
move
you.
on to the last presenter. Thank you so much.